Hey everyone, welcome to the videos on expected value, which is the mean, the variance and the standard deviation. Now we're going to go into how these different measures are calculated, and to start with I'm going to just go over what they actually are. So obviously the mean is just the average, and in statistics or in probability distributions, and particularly discrete probability distributions, it's referred to as the expected value. The variance is a measure of spread, so that's a measure of how far the value is spread from the mean, and also the standard deviation is also a spread of that. The difference between them we'll go into again soon. So to start off with, we've got the expected value being the mean. We use this notation here, so E of x, the expected value of x, and it can also be referred to as mu. So I would say that in general, the E of x is used for discrete probability distributions, which we're dealing with at the moment, whereas mu is used more for continuous probability distributions. The variance with these discrete probability distributions, again, I would refer to it as var x, whereas with a continuous probability distribution, I would refer to it as sigma squared. And this here is a formula that we can use to figure it out. So we've got E of x squared minus E of x all squared. The standard deviation is the square root of the variance. So you can see here, instead of being sigma squared, it's just sigma. And we can write it as square root of var x, but also it has this notation here of SD of x. Okay, so again, that's the discrete probability distribution, whereas this is continuous probability distribution. I am just saying that in a general sense, but they are really interchangeable. It tends to be that the E of x, var x, and SD of x tend to be used more with discrete distributions. Now, the reason that the variance and the standard deviation are different, while both being measures of spread, is that the variance comes by measuring the square of a difference, which it essentially changes the units that are being used. So when we take the square root, it turns it back into the units that were being used originally on the axis, and so the standard deviation is probably a more commonly used measure of spread. Now let's have a look at a couple of questions. So in a game at a local show, if this is going to work for me, hold on a minute. Right, we should be good now. So in a game at the local show, tickets can be bought for $2. There is a 14% chance of winning $7, and a 1% chance of winning $102. How much would you expect to win or lose per ticket? What I'm going to do in this question, I'm going to start drawing it up as a probability distribution. So we could have x being the amount that is 1, and the probability of x equaling x will be our associated probabilities. Now, a person can, buy the ticket and not win anything, so they would, in that case, lose $2. They could also win $7, which means that they've won the price of the ticket back plus an extra $5. Or they could win $102, which means that they've won the price of the ticket plus $100. Now the chance of winning winning $5 or winning $7 as it was 14%, so that's 0.14. The chance of winning $100 was 1%, so 0.01. We've used up 15% so far, so we still have 85% left. And, the expected value is really just going to be done by multiplying the probability by the amount of money that you win. If we lose $2 85% of the time, then we could go -2 times 0.85, and that should tell us how much we'd expect to lose. Then we're going to add on 5 times 0.14. And we're also going to have 100 times 0.01. So doing that calculation, we have -2 times 0.85, which is -1.7, plus we've got 0.7 there, and then we're going to have, it's just going to be 1, isn't it? So, based on that, it actually comes out to be 0. So you should be breaking even, which means it's not really a good game for anyone. Anyway, we'll leave it there and pick up again after. See ya.